Ever feel like your SQL queries are just crawling? Or maybe you're staring at a business question and you know the answer is in the data, but you're not quite sure how to get it out? Well, you're in the right place. In this explainer, we are going way beyond the basic select statement to cover the concepts that'll really level up your skills.
These are the kinds of topics that pop up in technical interviews all the time. They're also absolutely essential if you want to build really high-performance, data-driven applications. So let's dive right in.
All right, here's what we're going to tackle. First, we'll make our queries fly by talking about indexes. Then we'll get into some advanced ways to pull exactly the data you need. After that, we'll unlock some powerful analytics with window functions. And finally, we'll master a special type of join and talk about data integrity.
Okay, first things first, performance. If your queries are taking forever, the first place you should always look is your indexing strategy. This is probably the single most effective way to speed things up.
So think of a clustered index like this. Imagine you organize all the books on your bookshelf alphabetically by title. The books themselves are physically in that order, right? A clustered index does the exact same thing to your data in a table. It physically sorts the rows. And because it dictates the actual physical order, you can only have one clustered index per table.
Now, a non-clustered index, that's a whole different story. This is like the index at the back of a textbook. It doesn't change the order of the pages, right? It's a completely separate list that just tells you where to find the information you're looking for. It's just a pointer, which means you can have a bunch of them on a single table to speed up all sorts of different queries.
So here's the bottom line. You should use your one and only clustered index on a column where you're often searching for a range of values, like dates or IDs. For everything else, like looking up one user by their specific email, a non-clustered index is absolutely the way to go. Okay, our queries are fast. Now, how do we make them smart? Let's talk about some more advanced ways to pull the exact data you're looking for and do it efficiently. Here's a situation you've probably run into 100 times. You don't know the full, exact name of something, but you know a word that's in it. This is a perfect job for pattern matching. The magic here is the like operator. It uses these things called wildcards. So if you're looking for any product with shirt in the name, you'd write where name like % shirt %. That little % sign means match any characters here. So it'll find t-shirt, polo shirt, you name it. The underscore, on the other hand, matches just a single character. Now let's switch gears to something called a correlated subquery. This is basically a query inside another query, but with a twist. The inner query depends on the outer one. It gets rerun for every single row of the outer query. So you can answer questions like, show me employees who make more than the average salary in their own department. Super powerful, but be careful. They can get really slow, really fast. Ever need to find out who didn't do something? Like which customers have never placed an order, or which products have never been sold? That's exactly what an anti-join is for. It's a pattern, usually a left join, that's designed specifically to find what's missing. So you've got two tools here, exists and in. They both kind of check if a value exists in another set of data, but they work very differently under the hood. Exist just checks if its subquery returns any rows at all. It's a simple true or false. In actually compares a value against a list of results. The really big difference, though, is how they handle nulls. And you'll want to pay attention to this one, because this is a classic interview question. If you use not in and your subquery happens to have a null value in it, your whole query can break and return nothing. Not exists doesn't have that problem at all. It handles nulls gracefully, which makes it a much safer bet. Okay, now for one of my absolute favorite topics in SQL, window functions. Seriously, these things are like a superpower. They let you do some incredibly complex analysis right in your query without all the messy joins. So, window functions let you do calculations like a running total or a moving average across a set of rows. But the beauty is they do it without collapsing all your data down into a single result. You still get all your original rows, but with a new calculated column right alongside them. It's all done with that over clause you might have seen. A great example is ranking. Look at the slide. Row number just gives every row a unique number, 1, 2, 3, 4. Simple. But what if there's a tie, like the two scores of 95? Rank and dense rank both give them the same rank, rank 1. The key difference is what happens next. See how rank skips to 3, leaving a gap? Dense rank doesn't. It goes right to 2. And then you have lag and lead. Oh, these are fantastic for any kind of time series analysis. Lag lets you peek at the data from the previous row, and lead lets you look at the next one. This is perfect for calculating things like month-over-month growth without having to do a complicated, messy self-join. All right, for our final technical section, we're going to look at a very specific, very powerful type of join you might not use every day, but it's crucial to know. And then we'll talk about the conceptual glue that holds your entire database together, referential integrity. A cross-join sounds complicated, but it's not. All it does is create every single possible combination of rows from two tables. You just take every row from table A and pair it up with every single row from table B. It's super handy when you need to generate all possible permutations, like product SKUs or test data. And boom, here's a perfect, simple example. You've got 5 t-shirt colors and 4 different sizes. A cross-join instantly gives you all 20 of those combinations. It's just simple multiplication, and the database does all the work for you. So why do we even bother with things like primary and foreign keys? Well, it all comes down to this one crucial concept, referential integrity. It's basically the database's promise to you that your data relationships will stay consistent. It's the rule that prevents you from having orphan data, like an order that doesn't have a customer. And here's exactly how it works. Step 1, your customers table has a primary key that makes every customer unique. Step 2, your orders table has a foreign key that points back to that customer's primary key. And step 3, the database itself enforces that link, making it impossible to create an order for a customer who doesn't exist. It keeps your data clean and trustworthy. So let's take a step back. We've covered a ton. We talked about indexing to make things fast, advanced retrieval to be precise, window functions for really deep analysis, and the joins and keys that make sure your data structure is solid. These aren't just abstract ideas. They are the real professional tools of the trade. With all these techniques in your toolkit, you can now go way beyond just fetching data. You can start asking much more complex, much more powerful questions. So the only question left is, what are you going to build? And what insights are just waiting for you to uncover?